Hello everyone, so this is Sir Gabs again. Welcome to my channel. This is my third video about parabolas. In the previous videos, I actually discussed the definition, the eccentricity of the parabola, the elements of the graph of the parabola, as well as the standard equations and the general form of equation. Now in this video, I will be discussing the graphs of parabolas. We have here graphing parabolas. Our goal is to sketch the graph of the parabola whose equation is quantity x minus 1 squared equals 8y plus 24. So this is example number 1. And how do we graph it? Of course, we have to take note of the equation. You can just write it this way. X minus 1 squared equals 8y plus 24. So the image of the equation looks like this equation. My quantity x minus h squared equals 4p times y minus k. So notice that the x variable is in the degree of 2. So obviously, this is the format of the equation. And then we have a positive numerical coefficient of the y variable here on the right hand side. So we assume this is positive 4p. Okay? You may transform this equation into this format by applying factoring. No? You can factor out 8 here and you will come up with this equation. So you have x minus 1 quantity squared equals 8 times y plus 3. Okay, so there's a common factor here. 8y is divisible by 8 and 24 is also divisible by 8. So you can factor out 8 and then divide 8y by 8. Of course, you have y, and then 24 by 8, so you have 3. If you want to check or if you want to verify if what you have done is correct, then you can distribute the value, the number 8. So 8 times y is 8y, 8 times 3 is 24. So this is actually correct. The next to that, guys, you can already get some information from this standard form of equation. So first, you can identify already the opening. So as I said, remember, focus on the variable in the degree of 1. And this time, that is the y variable. So the y variable refers to the y-axis, which is vertical. So when we say vertical, the direction is either upwards or downwards. Now, we have here a positive 8, so which means 4p is positive. So that means it is upward, or the opening is upward. Okay? Now, the vertex is very clear to be 1 and negative 3. So the same as how we get the center of the circle, all you have to do is, just to make it short, and just change the sign of the number here. So actually, looks like negative 1, but just get 1 here. Then positive 3, just get negative 3. Okay? Then the latus rectum also is actually very, very visible in the standard form of equation. Remember, the length of the latus rectum is always 4 times the focal distance. And when we say focal distance, that's the variable p in our class. So here, we have 4p. This is basically just the latus rectum. So you have actually the reflection of 4p here, which is 8. So 8 is just the reflection of 4p, or in other words, 4p is just equal to 8. Okay? So 8 units is just the length of the latus rectum. Again, remember that the latus rectum has a length of 4p. And whatever the value of the numerical coefficient here actually is just the length of the latus rectum if you have formed the standard form of equation. Okay? So from here, we can already draw the rectangular coordinate system. I have here the ready-made rectangular coordinate system, and then plot the vertex. So the vertex is basically at 1, negative 3, so it's just here in the fourth quadrant. Okay? So 1 and negative 3. This is the vertex then. After that, you compute for the focal distance. So how do we do that? Remember, 4p is equal to 8, right? Okay. So again, always remember that this numerical coefficient here is always representing 4p, or the length of the latus rectum, provided you have acquired this format or you have obtained this format. Always consider this as the length of the latus rectum. That's 4p equals 8. And then algebraically, you can divide both sides by 4, and then you will have p equals 2. Okay, so the focal distance is equal to 2. So this is the time that you will use the concept or the opening of the parabola. Remember, the parabola is opening upward. So if this is our vertex, we expect that the parabola is going there up. No? So if it's going there up, then remember the focus is always, as I said last time, it looks like the focus is being eaten by the parabola, or it's like it's the inside the parabola. So if this is opening upward, we expect that the focus is just here, somewhere here above also. Okay, or just maybe consider that whatever the opening is also the movement of the point going to the focus. In other words, if this is vertex, you have to move upwards 2 units going to the focus. Okay, always remember, how did I know that I have to go upward? Well, again, I am basing on the opening. So whatever the opening is, that's already the direction of the vertex moving to the focus. So from the vertex here, you have to move 2 units upwards. So that should be 1 here and then 2. So there should be the focus in there. Okay? So after the focus, you can actually, if you can remember, no? The distance of the focus from the vertex is also the distance from the directrix to the vertex. Okay? So it means if there is 2 units going to the focus, moving to the opposite direction will be the position of the directrix. But guys, anyway, I have been observing my students before, and they always consider directrix as a point. Now, directrix, most of the students, most of the mistakes that my students made before, they consider directrix as a point instead of a line. Always consider a directrix as a line. It's never a point. So this is only, it's like our hint, or this is our guide in just drawing. I mean, this is just our guide in drawing directrix. So directrix is actually this one. Okay, because this is only a point that identifies the distance from the vertex. So moving down, that is the vertex. Well, anyway, how did I know that it's horizontal? Well, just use simple logic. Okay, so if I will do it vertically, then it passes through the vertex, right? Again, if I do it vertically, it passes through the vertex. So remember, directrix is the opposite, or it will never pass through the vertex of the parabola. What passes through the vertex is actually the axis of symmetry. Okay, and then, well, if you have remembered the complete image or the complete elements of the parabola, you must have remembered that when the parabola is opening upwards, the directrix is always horizontal. But if not, then just use simple logic. If I do it vertical, it passes through the vertex, so it's not possible. So I should do it horizontally. Okay, so hopefully it helps. Then we have the axis of symmetry. So this one is the axis of symmetry already, because based on the takeaways that I gave to you last time in the first video, axis of symmetry is passing through the focus and the vertex of the parabola. Okay, and it is actually perpendicular to the directrix. So if the directrix is actually horizontal, then it follows that our axis of symmetry is vertical. So from here, remember that we have to locate also the endpoints of the latus rectum. So these are actually the endpoints of the latus rectum. But question is, how did I do that? How did I find these 2 points here as the endpoints of the latus rectum? Guys, you have to remember that the latus rectum is 8 units. Okay? So it's 8 units passing through the focus. Okay. So you have to remember that one, the latus rectum is always passing through the focus. Now, if it is 8 units, then it should start 4 units from the left and ends 4 units going right. Or in other words, from the focus, just count 4 units. Again, where did I get 4 units? Just consider the half of the latus rectum. Just divide this by 2. So 8 units divided by 2, of course, is 4. Okay? Why? Because we start at the midpoint of the endpoints. We start at the focus. From the focus, count 4 units going right. That's 1 unit right, 2, 3, and 4. So this is one endpoint. And also on the left side, you have 1, 2, 3, and 4. So this is also the other endpoint. If you connect this two endpoints of the latus rectum, obviously that's 8 units. Okay? Then after which, guys, once you have already the endpoints of the latus rectum, you can already draw the parabola. So that's already your parabola. Now, after drawing the parabola, you can just label everything here. The focus actually, no, so you know already the vertex, it's already labeled here as 1, -3, but the focus we do not know the coordinates. If you have watched the review portion of our lesson, you can actually see that this is moving upwards, vertical, so there's a change of y. There's a change of y. In other words, we have to change -3 here from the vertex. So starting from the vertex, there's a change of y moving up. That's positive, okay? So how much did we move? We actually moved 2 units, so plus 2 units going up. So from -3, you add 2, it's -1. In other words, the coordinates of the focus is at 1 and -1. But if you will try to look at the graph here, it's very clear that it is 1 and -1. Okay, the review portion is very helpful, especially if it involves fractions or radical expressions. But as for now, maybe it would be easier if you'll just what's this? If you'll just identify the coordinates using the graph or using the image here. But if not, then you have to use the concept of change in y and change in x based on the review that I gave. Then we have R1, okay, so this one here, and one endpoint of the latus rectum. Well, actually the standards here is we have to label first the right at the point at the right side. So in other words, this is R1 and this can be our R2. Okay, so to solve for R1, of course, we start at the focus, correct? No? So we started at the focus and then we move 4 units going right. So 4 units going right, that means horizontal movement. So if it's horizontal movement, that is change in x. So from the focus, we will change the x coordinate. So from the focus, change the x coordinate. Okay, change this one here. Now, how much did we move? We actually moved 4 units going right, so that's positive going right. So you can just add 4 from 1. So that's 1 plus 4 units right, so that should be 5 and -1. So of course, all you have to do is to copy -1 because there's only a horizontal movement. Next, on the left side, it's R2 this time, and R2 is -3 and -1. So how did I do that? Again, from the focus, this is moving left, so that means you have to subtract. Okay, so that should be 1 subtract 4 units movement. So 1 minus 4 is -3. Of course, you only copy -1. So that's the importance of knowing the movement of the point, no? So if it's horizontal movement, remember there's a change in x coordinate. If it's vertical movement, there's a change in the y coordinate. Okay, and then if the movement is going right, there's a positive change, so that means plus, you add. And then if it's going left, you subtract. If it's going upwards, you add to the y coordinate, and then if it's moving downwards, you subtract the movement to the y coordinate. Then we have directrix here. So here in the directrix, this is a line. So you should get the equation of the directrix. Okay, this time equation of the directrix. You can actually see the equation by just looking at the line. It crosses to the y-axis, or it intercepts the y-axis. So basically, the equation with directrix looks like this one. Y equals, okay, remember, how did we get this point? We get this point from the vertex. Okay, so there's a simple way of doing that. Remember that we get this directrix from the vertex. That is the starting point. So what is the y coordinate of the vertex? That's actually -3. So that's why I started at -3. Then after that, I actually moved down, correct? So from the vertex, I move down going to this small point here to locate the directrix. Now, I am only interested on the value of y. Okay, why? Why only y? Because of course, I am interested with the y variable because the directrix is intercepting the y-axis. If you remember, to create or to get the equation of the line or the horizontal line, it should be in the form of y equals b. So if it is y equals b, then I should locate the intersection of the line and the y-axis. So it's easy if it's like this one. It's very clear. It's very clear that it is in -5. But if it involves the fraction and the radical expression, you have to apply the discussion and the review. So how do you do that again? You have to consider the starting point, which is the vertex. What variable are you interested to? This time you are interested to the y variable. So the y variable of the starting point, vertex, that's -3. So y equals -3. Now I move down 2 units. So moving down means subtracting. So how many units? That's 2 units. So that should be -3, the starting point, minus 2, representing moving down 2 units. Okay? So this time you will come up with y equals -5. And it's very clear here in the image also that the line Directrix is really passing through or crossing to -5 of the y-axis. Then later part, you can actually apply additive inverse. You have y plus 5 equals 0. Or here in the Philippines, we know that one as transposing. Okay, but again, the formal way of doing that is additive inverse. Axis of symmetry, the equation of the axis of symmetry. Okay, actually this one is easier compared to the Directrix. All you have to do is take note, it passes or it crosses to the x-axis. So it's very clear. It's very clear that it is in 1. But all you have to do, even without drawing it, you can already know by just looking at this squared term in the parentheses or terms in the parentheses. So actually, if you want to be formal, all you have to do is it is passing through the vertex. Okay, it passes through the vertex. What variable are you interested to? You're interested to the x variable because it intercepts the x-axis. So x here is actually 1. So that means x is equal to 1. Okay, and then later part you will come up with x minus 1 equals 0. But if you want to know the shortest way of getting the equation of the axis of symmetry, always look at the binomial in the parentheses of the squared term. Okay, so this x minus 1, just equate it with 0, and that's it. That's already your axis of symmetry. So okay, what if there's only monomial here like x squared? Then of course x squared equals 0. I mean x squared means x minus 0 squared. So the axis of symmetry is x equals 0. If that happens, but in this case we have x minus 1 quantity squared. So as I said, whatever is inside in the parentheses, that's already the equation of the axis of symmetry if you equate that 1 to 0. Okay, that happens to the standard form of equations of the parabola. So that's the first part, that's the first example. Now, I will be giving you the second example in the next video anyway. So see you in the next video, guys. Goodbye.